Okay, welcome back. This is the problem that you were supposed to do on your own, so let's go ahead and do it together. Step one here, we want to solve for a variable first, and I see that this x right here is going to be easy to solve for. So I subtract 5y from both sides, and I get x equals negative 5y minus 9. Now, this expression that I got, I'm going to plug it in to this other equation, into the x value there. So I get 4 times negative 5y minus 9 plus 3y equals negative 2. Again, x and this expression are the same thing, so I can replace it here. Distributing the 4, I get negative 20y minus 36 plus 3y equals negative 2, which gives me negative 17y minus 36 equals negative 2. Adding 36 to both sides gives me negative 17y equals a positive 34, and therefore y equals negative 2. So that is half my solution because I need a y value and an x value. So my y is negative 2. And then to find my x value, I'm going to take this and I'm going to plug it back into my original and get x equals negative 5 times negative 2 minus 9. And that's going to be 10 minus 9, or 1. And so there's my solution, 1, negative 2. And again, this is the point where the two lines will cross. So that's going to be like right there, and then these two lines, these are not the right two lines, but this is the intersection point of those two lines. By solving it this way, we've found that intersection point. Okay? So if you having a hard time with substitution, make sure you address it with your teacher as soon as possible. Otherwise, let's move to elimination. Now, elimination is another method for solving, and we use it in certain situations. So first of all, we need to make sure that both of our equations are in standard form. ax plus by equals c. If you have it in slope-intercept form, you need to solve it so it looks like this. Okay? Otherwise, elimination becomes very difficult to use. The overall goal of elimination is to add the equations together so that when you combine the like terms, something becomes 0. Now, to do that, step 1, you might have to multiply one or both of the equations by a constant to obtain coefficients that differ only in sign for one of the variables. So what we mean by that is you get 3 and negative 3, right? So the only thing that's different is the sign. They're opposites of each other. Okay? Once you have that, you add them together because when you combine like terms, one of the variables will become 0. Okay? That gives us an equation with a single variable. We solve for that. Then we do step 3, which is the same as in substitution, where we plug it back in. So let's go ahead and do an example of this. Here we have the system 3x minus 7y equals 10. Also, 6x minus 8y equals 8. When I add these two equations together right now, I get 9x minus 15y equals 18. And that doesn't work. We haven't eliminated anything yet. So what we need to do is change the equations so that they do. You have to look at this set of equations and go, what number can I multiply one of these equations by, or both of them by, so that when I add them together, it becomes 0. So here's what I notice, right? I notice that this x value is a 6, and this one is a 3. And that if I were to multiply the top equation by a negative 2, I could make this negative 6, and I could make this positive 6. Doing that allows me to add them together to eliminate. So let's do it, right? We're going to multiply everything in this top equation by negative 2, and then we'll have negative 6x plus 14y equals negative 20. And then my bottom equation will be 6x minus 8y equals 8, right? So I didn't change the bottom one. But notice what happens right here. Negative 6x, positive 6x, that will become 0 when we add them together. So that's what we do now. We add them together. This becomes 0. It cancels out. This 14 plus negative 8 becomes 6y, and this negative 20 plus 8 becomes negative 12. This is an equation with one variable that we can now solve. So we divide by 6 and get -2. That's half my answer, right? This is the same as now what we've done with substitution. If I take this value and I plug it in up here, and it doesn't even matter which one I plug it into, we'll end up with the x value. So let's plug it into that top equation. 3x minus 7y equals 10. We're going to plug the -2 in for y. So -7 times -2 equals 10. So that's 3x plus 14 equals 10. Subtracting 14 from both sides gives me 3x equals -4. And dividing by 3, I get x equals -4/3. So that is my x value for this particular system, right? So in elimination, the goal is to create a situation like this, where the numbers are the same, they're just opposites of each other. We can do that sometimes by multiplying by 1, but we could also do this for the y variable if we wanted to, right? Let's just really quickly do that. So here's my answer, -4/2. What we can do, we need to make 7 and 8 the same number, so we have to look at their factors. 7, 14, 21, 28, 35, 42. It's going to be a while before I get there. 49, 56. Well, and then the factors of 8. 8, 16, 24, 32, 40, 48, 56. Oh, look, they're both 56. Which means if I can make them both 56, I can eliminate them. So to make -7 56, I need to multiply it by 8. And to make -8 56, I need to multiply it by 7. But remember, I want opposites, so this one's going to be negative. I'm going to make this one multiplied by -7 so that it becomes positive. Now we get 24 minus 56, sorry, 24x minus 56y equals 80. And then I get -42x plus 56y equals -56. So notice again, I get this situation right here where I can add these together and eliminate. So I won't finish solving this, but we could have done the y. It would have been more complicated in this case, but if we have to multiply both equations, we will. All right. All right, so I've got a practice for you back on your canvas. Go do that, and I will see you in the next video.